So this is one of the advanced tutorials where we will talk about how to use OHDSI standardized vocabularies for research. And we will mainly focus on how to construct concept sets for your phenotypes when you actually do research. We have, of course, we need to first introduce our faculty. And we have actually all girls this time. It's kind of unusual, but this time we have myself, we have Masha here, we have Polina and Azza, and we will, together with our wonderful teaching assistants that are nowhere to be seen except for Daria, we will make sure that as you walk out this room at 5 p.m., you can do more with vocabularies and you can create better concept sets than what you can do now. No judgment in terms of what you can do now, but I'm sure we will be able to tell you something that is useful. And as I said, the tutorial is really around using the vocabularies for creating concept sets. And that, of course, very much stems from the research question. When you talk about phenotyping, when you talk about creating cohorts, creating concept sets, of course, you first start with your research question that you want to study. So throughout this tutorial, we will use this research question that actually naturally popped up when I was reading this update on the guidelines for lupus. Oh, and here's one of our TAs. Let me show you his face again. So in this update from 2023, still in 2025, it's pretty much the same thing as in 2023. They talk about the current guidelines for lupus, which is an autoimmune disease. And the very first thing that the authors say is that, well, since 2019, the previous year of the previous guidelines, there were many more new drugs for lupus. And in fact, even though there are many more drugs, we actually don't know much about whether those drugs are effective compared to each other, how often they're used, what kind of patients take them. And they say explicitly in these recommendations is that we need to learn more about how those drugs are used. And we see another faculty coming in. And naturally, the very first thing we can do when we think about all of these new drugs for lupus is simply answer the question, well, what kind of drugs are used in real-world data to treat patients with lupus? And what we can do to answer this question is to perform a characterization of the treatment patterns in the OHDSI network in patients with lupus, just simply to see how many patients get treated, what kind of drugs they use, and in what kind of sequence. And we do have the analytics for that. So there is a package called Treatment Pathways that is a standardized package. You can see the snapshot of a nice picture that you can generate in Atlas. And specifically here, it's a group of patients that have a diagnosis of lupus and are taking different drugs, and different colors represent the drugs they are taking and the sequence in which they are taking these drugs. So actually what you can see here is that for this group, the majority of patients are taking glucocorticosteroids as the first line. And the point we're trying to make here is that we in fact do have the tooling to directly answer the question that the authors of the guidelines of American Rheumatoid Association have in mind as a very important question for these patients. And there are studies that utilize these packages that we, as a community, published already. And in fact, we have the tooling for many other types of questions. So for example, when you studied how those patients with lupus are treated, then you can ask the question, well, what kind of outcomes do they experience? And then you can ask the subsequent question, well, do we have different risks of outcomes in patients taking different drugs for lupus? And we can go on and on with all sorts of questions. And for most of the designs, we do have standardized tooling, and you can see the names of the tools and methods highlighted here as well of some of the papers. But what needs to happen for this tooling to work is that we also need to have standardized input. And in this very specific case, the standardized input is the standardized way to find these patients in the data. So to study the patients, to answer this specific question of how patients with lupus are treated, we need to find the patients with lupus, and we also need to find the patients that are taking the drugs of interest, and there can be corticosteroids or other drugs of interest. And this is what we're really going to focus on here, because we do have standardized ways to identify these patients of interest in the data. And Azza here, who's our faculty, is also leading phenotype work group, who talks much more in details about the phenotyping process altogether. But to briefly give you an idea of how we do phenotyping in Odyssey, we start with the inputs. The inputs are the description of what you want to study, the clinical definition of a disease or maybe state. So for this question, you explicitly need to outline what is lupus and what kind of patients you expect to get when you ask for patients with lupus. We also, of course, conduct prior literature review to see what kind of codes, what kind of definitions have been used, what kind of performance they had, and any other details about the previous research. And then it feeds into the pipeline where we start with creating the concept sets, and we stack these concept sets together to create a cohort definition. And this is one of the things that usually trips people over if they're not accustomed to our wording around phenotyping, is what is the difference between the cohort definition and concept set? Well, the cohort definition or phenotyping algorithm is the specification of how you find these patients. And the cohort not only needs to have codes like ICD codes, the cohort needs to have the entry event for patients upon which they enter the cohort. There needs to be some criteria that they have to satisfy to be in the cohort, and then there's always an exit where you believe that they no longer have the disease of interest. So while we're going to primarily focus on the concept sets, we use them to create cohort definitions, to then execute those definitions against the database, and to evaluate performance. And as an output, we get the definition itself, we get the evaluation report if we performed evaluation, and we get these cohorts of patients with the durations of time that they satisfy that they have the disease of interest. We have tools for that. If you're interested in the phenotyping process, Azza is your guy, and the phenotype work group meets every Friday. But here specifically, we will focus on the first building block, concept sets. And you might be surprised that, oh, well, we're going to spend from 1 p.m. till 5 p.m. talking about concept sets. Yes, because there is quite a lot to it. To start off, talking about what the concept sets are, it's simply a list of one or more concepts. Also, if you have any questions, you can raise your hand at any point of time. So the concept set is one or more concepts, and when we say concepts, we mean codes that are used in the source data in electronic health records, claims, registries, whatever kind of data you have. For example, if we look at the data in the US before 2015, the codes that you can find for conditions will be ICD-9 codes. After 2015, ICD-10 codes in data in UK will be coded in the read codes. So concept sets are the list of one or more of these codes. And what we do in Odyssey is that while we have all of these sources, at this point, I think we have 450 data sources standardized to OMOP CDM. So you can imagine that we have lots of different countries talking very different languages. We already mentioned ICD-10, ICD-9, READ. There are many more vocabularies that are used across the world. So what we do is we find one reference standard so that whenever you do research, you can use that reference standard regardless of the country you're coming from. So it doesn't matter if you're doing study in UK or US or Australia, if your data is converted to OMOP CDM, the standard will be one common reference standard. And in this specific case for conditions, it's very likely that it's going to be SNOMED, and the way we'll link the source data to this common reference standard is through the maps-to relationship. I know these are basics, but we want to make sure that everybody is on the same page in terms of the basics. Now, we not only curate those mappings from the source data to the common reference standard, we also leverage the existing structure of those vocabularies. So here, for example, you can see additional relationships within SNOMED subsumes, which indicates hierarchical relationships. And we also add vocabularies to it that can sit on top of reference standard that are classificational vocabularies. For example, in condition domain, it's MADRA that can be used to find groups of diseases. SNOMED can be used for that too, but the point here is that we sometimes attach these classificational terms on top of the reference standard to make it easier for you to create concept sets. And the way it lives, again, very basic, the way it lives in the vocabularies is that you have all of the concepts, standards, source, classificational in the concept table. You have all the relationships, maps to, but also all of the other relationships in the concept relationship table. And you have the hierarchy that is computed in the concept ancestor table. This probably is the last time you're gonna hear these names, because in this tutorial, we're not gonna query these tables directly. Instead, we're gonna use the tools that we have and the user interface that we have so that you don't have to touch them directly, you don't have to write SQL queries, you don't have to mess with the dialects, but everything's got to be done in the user interface. So even though we put this table names on the slides, this is really the last time you're going to see them. And this may sound and look quite simple, but in fact, if you look at the totality of vocabularies, there are lots of vocabularies. There are 11 million concepts. There are 4 million mappings. There are almost 100 million, I cannot believe this number, hierarchical links. So in fact, the structure is quite complex. And when you peruse this structure, it is quite hard to find all of the relevant terms, to navigate it, to make sure that you create good concept sets, that you find all of the things that you want. So that's why we built this tutorial to actually provide you with some guidance on how to make sure that you capture all of the relevant codes and to teach you how to easily navigate the key parts of the vocabularies most pertinent to your research. And with that, we move into the agenda. So we covered the introduction. We're now going to do the first block of conditions. Then we're going to have a break. If we are good on time, we're going to have a longer break, which is always nice. Then we're going to do the block of drugs and measurements. So these are really three domains, the main domains that we feel people need the guidance in. Each of the demos will be followed by the exercise where you will do hands-on exercises. We will walk around and help you to make sure that you get the most out of this tutorial. And then, of course, we're going to have discussions. So if you have unrelated questions and we have time, we can address that too. With that, I will pass it to Azza, and as she walks to this podium, are there any questions so far? Yes, there is a question from a person from Colombia, so I'm very disappointed that you have a question.
So no procedures are going to be covered?
We don't have time, but we can talk about procedures. Also, they kind of do suck. So they're not in this tutorial for a reason, because when they suck, I mean that we don't harmonize them that well, but we can talk in general what kind of things to watch out for in the procedure domain. But for the reference, when Azza, she just said when she was creating the surgery concept set for the last time, it took her 3 months. So this is one of the reasons why procedures are not in this tutorial. But if you feel like it, we can cover it at the end. Yes? Mm-hmm.
Actually making a decision about what concept maps to what vocabulary, like is that done within the Odyssey work groups, or is that done clients paying for services? Like
So historically, it's been a mix. Right now, we have the following procedure. If you add new content with the new mappings, you're fully responsible for the mappings. They can be as silly, as right, as wrong. It's fully submitter's responsibility. But now because the assumption is that it doesn't actually affect the community because you're adding new content that you care about. But if you're changing the mappings that already exist, in this case, we have the validation procedure with the work group to make sure that the community is aligned with these changes. So it's different based on whether it's new mappings or existing mappings.
Just a quick question. Is there a way we can access the slide deck on our PCs?
Yes. While Azza is giving her demo, you'll be listening. All right. You will not be watching for the slide deck. You'll be listening, but I will share it in the Teams, and then I'll give you guys the link so that you have it for the exercise to also back reference.
Thank you.
Thank you, Anna. I might need you in a second, but this is Mac, right? Hi, everyone. Thank you for coming to this, the most important tutorial. My name is Azza Shoaibi. I am an Odyssey collaborator for some time. I work with Anna in Johnson & Johnson, and a lot of our work focuses on phenotyping and the vocabulary. So I would like to share some of the stuff we do with you all today. Okay, so Anna showed you the complex mapping that exists in the vocabulary. So imagine you are to try to build a concept set for lupus or systemic lupus erythematosus. And imagine you want to see what are the terms that you need to include in that concept set. Given the different vocabulary that exists in in all the Odyssey network that comes from different countries, and if you to just check across all those tables that Anna said you would never touch, and just do even a smart match or search for systemic lupus erythematosus. If you're looking at ICD-10, you'll find a code like UM32 that says systemic lupus erythematosus. If you're looking at ICD-9, you will find another code that said 710.0, systemic lupus erythematosus. If you're sitting in the UK and you're looking at data with READ, you'll find another code that also sounds the same, and so forth. So Odyssey made it much easier with standardizing vocabulary because all of those different terms that all represent the idea of systemic lupus erythematosus map to a standard reference in SNOMED, which is called systemic lupus erythematosus. So it doesn't matter where your data coming from. If you are looking at systemic lupus erythematosus, you can find the standard reference SNOMED code, and you will be grabbing all those other source codes. That's nice. But if you're doing this on your own, you're like, okay, I find that code, I'm gonna take it in SNOMED, and I'm gonna take it all as descendant. But wait, there's another ICD-10 code that says lung involvement in systemic lupus erythematosus. You might be worried that maybe you didn't capture that code because you don't know what it maps to. But indeed, it maps to a very similar term in SNOMED that says lung disease with systemic lupus erythematosus, and that happened to be a child of systemic lupus erythematosus. So you'll be okay, fine, I did capture it because I took the parents, all the children, I'm not missing any code. Then a friend come and tell you, wait a minute, there is this code that says endocarditis due to systemic lupus erythematosus. And actually, it does not map to, it's not a child of systemic lupus erythematosus. Oops, you missed that code. It has a relationship in the vocabulary tables that says due to. Did you bring due to? And so it might take you months, maybe many days, trying to see if you actually captured the codes. And that would not be standardized research. So we're not gonna do it that way. We actually have a workflow using Odyssey open source tools to help you to actually capture all the codes with way less manual work and way less back and forth between you and your team and maybe your clinical partner. So the workflow starts with 2 inputs. Many times, if you're actually in the world of applied research, clinical research, there might be a situation where people come to you and you say, they say, I know the code list for lupus. Here it is. Somebody published that list, and it's in the public domain, and they validated, and I want those codes for SLE. Fine, that could be an input for your process. We don't believe that you should take any list out of any publication that was done in some licensed data source sitting in the US or sitting in some Scandinavian country and come and apply it as a OHDSI network study, because data come from different countries, and a code list that was done for a certain data set in a certain country might not be capturing all the right terms. But it's absolutely valuable, and you should have it as an input to your process. The other input in the process is the clinical description. You should never touch codes, looking for codes for any clinical idea before you understand what is that clinical idea is. That is your term of reference. People in code lists and phenotypes always talk about gold standards or gold code lists, and in reality, there exist a cold code list, because if we have infinite resources, we will do chart reviews for every code list and know how good every code is. But in reality, we can't do that. The actual gold standard, the actual reference to tell you if that is a right code or wrong code, is your target, is your clinical idea, the description that you're trying to capture. And so you need something that describes your intent. So let me give you an example. So the workflow is you have those two. Then you're going to go and use Atlas as your open source tool to start using those two to start compiling your concept set. Okay, so here's an example of how would a clinical description as your input for SLE. Something like systemic lupus erythematosus is a chronic autoimmune disorder characterized by systemic inflammation affecting multiple organ systems. Unlike localized autoimmune disease, which affects specific organs or tissue, SLE is systemic disease, and so forth. But the point here in that document you have describing what SLE, you already know, you might not be related to any clinical domain, but you already know that you're trying to get SLE, and you know that this is something related to a systemic, and you're not, already the clinical description is telling you that there is some version of disease that is localized, and that's not your clinical intent. So you already now have some granularity about the clinical idea that probably you need to keep in mind as you go to code list. This is just an example of SLE, but almost every clinical phenomena will be characterized in a way that describe what is your clinical intent and what might be related but not what you want. And before you touch the data, you have to have some clearance about that with your clinical partner, because that should determine what goes in, what codes don't go in. Because once you touch the data, you'll see the phenomena of all these clinical conditions represented in certain codes. And unless you understand your target, you won't be able to make decisions. Of course, you can always have a clinical partner that can help you in that process. Okay. We talked about literature review. In OHDSI, we've been doing phenotyping for a long time, and we're not calling that you need to do a full systematic review of every existing code list that exists for a condition of interest, but we try to help our partners and collaborators a little bit across the community, is that we have a query that is in the public domain that you can run on PubMed that will identify published papers that have in their material, whether it was supplementary material, all in the paper itself, code lists representing clinical outcomes or clinical conditions. So we have that available for everybody. Now with the use of GenAI, you can even do this much fancier and nicer and obtain what's in the literature. But basically, this is even somebody coming and telling you, here is the code list in ICD-10 that I want for SLE, or you on your own do that work and try to understand what has been done before and what were the codes included for SLE, so you take it as an input. Okay, now you have these two things, and here's like an example of SLE. You'll see that this is a paper that defined SLE with two codes of M32.1 and M32.9. That's just an example. Okay, so now we're gonna all together do the exercise of creating code lists for SLE all together, and I need demo atlas. You can play along with me or don't, because you're going to do it for rheumatoid arthritis in the next session. Okay, so here is Atlas. I hope all of you already know what Atlas is, but it's an open source tool that allows you to do all sorts of things, including selecting and generating or curating a code list. So you're gonna hit on search, and I'm gonna copy and paste because I'm gonna definitely misspell erythro. Hold on, Anna. Whoops. Can I go back to the slides? Or you guys can help me here. Systemic, correct?
Yes.
Lupus. Lupus. No. Man, I did it correct first time. And then US or OS?
You.
Okay. Man, my child would fail me at this point. Okay, and then that's the hard one. Okay. Erythematosus. This looked good. Okay. Here. You do not click search. You're not going to click search. You're going to click the cart. So what is the cart doing? Because we have amazing researchers in this community, like Anna and others, they actually came up with a recommender system that instead of you searching terms, term by term, across the vocabulary tables, it gives you the reference standard that you want to start with. So instead of starting from the entire corpus of that vocabulary table and try to find terms, it's a recommender system that tells you if you want systemic SLE, systemic lupus erythematosus, you first want to start with this reference code, the standard code from SNOMED called systemic lupus erythematosus and all its descendant. So it automatically in Atlas takes you to the concept set. See, we started in search. It's going to take you to the concept set. That means it created an entry for the concept set, and it recommended that you start with this parent standard and all its children as your first step in your concept set building. And now you don't want to lose this, so you want to save it, and we're going to save it. Odyssey, oops. Oh my God, Anna, it's Ukraine.
You do tab. Tab.
Tab.
Macs are the best
I hate Max.
computers.
Hold
I
on.
don't know why people can't.
Okay, it's still Ukraine. Tab.
Or maybe caps lock? Caps lock, caps lock. Is it SLE?
Yeah,
No,
okay.
that's good.
Okay, we're gonna call it Odyssey 2025 Symposium. Doesn't matter. You don't have to spell it correct. Now, whatever. Okay, you can call it blah, 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 as my son would say. Okay, so you call it something, and then you save it. And now you have your first starting point. That's the first step in the process. Now, whenever you have somebody and tells you, here is your code list, if you want to make sure that this code list is correct, what are the two questions you want to answer? What are the two things you'd worried about? Whenever you look at a code list, what are the two things you'd worried about? Any idea?
Missing code.
Missing code. So having not included in code, we call this recall, or we call this completeness, or false positive. There are two things. You want to make sure there aren't concept sets that you do not include, and you're not including concept set that shouldn't be there. Recall, precision, accuracy, all these nice scientific terms. So first, we're going to focus on the first question. Second question, is my code list precise? Is that starting point precise, meaning that is everything I included is truly belong to SLE? To answer the question, you're going to go on the tab that called included concept. If you know anything about vocabulary and OMOP, you know that we use the SNOMED hierarchy in conditions which allow us to, instead of compiling concepts, we compile concept expression. That means that the code list is represented by a term and the hierarchy use and all its descendant. That is your concept set expression. But the full list of your codes, it's under something called included concept. So you'll find it here. And you'll find in this case that this concept and its descendant include 35 different concepts. And now you want to answer the question, are all those 35 legit or anything that has false positives? So,
There is a question.
oh, sorry.
I have a dumb question.
No dumb
the
questions.
Concepts and expression tab, you left the include descendants checked off. Is that a standard recommendation? Is that something we're generally going to want to do?
So remember, this came, I didn't even pick that. This came from the recommender system. And the recommendation from the system is telling you to include descendant. Generally, that's how it is. It's going to always recommending a starting standard reference and its descendant. And you deal with this as your starting point. If you were selecting concepts on your own, verbatim, one by one, and not using the recommender system, then every time you have to make that choice. Do I want the descendant or I don't want the descendant? So it's not like you always want to pick the descendants. As a best practice, before including descendant, you want to look at them. But if you're following this process, you're going with the recommendation. Generally speaking, if you're clinically interested in idea, then you can trust SNOMED that everything that SNOMED said is under that idea is maybe true, but you can look at it. Okay, so I'm going to go in the included list. And in this case, I see 35 codes, concepts. And because Odyssey is amazing, it's not giving you 35 codes, concepts and asking you, here, go ahead and think about each of that one. It gives you a way to prioritize those concepts when you look at them. How they are prioritized, they're using something called concept prevalence data, which again, Anna helped curating. Yeah, or yeah. So what we have here is the record count for every concept across the entire Odyssey network. So that gives you an idea of the utility or the prevalence, basically, of such concept across the entire community, which includes many different data partners. So now you know, and if you're doing this in your own Atlas instance, you can also do this on your own data sources. But if you're doing it in Demo Atlas, that will represent the entire Odyssey community data partners. So in this case, you'll see that the first code is systemic lupus erythematosus. It has 20,000. That's the highest, kind of most of the data is really loaded on that code. And then you can go down and check the 35. Because I'm a good student and I understand the clinical idea, one thing I might be worried about, does this code list include any local lupus, which I know is a close idea, but that's not what I want. So I can go ahead and write something as local and see if that term exists. It doesn't exist. Very good. I can look at something that say cutaneous. It also doesn't exist. How we can go down. And how do I can go down the screen?
You scroll?
It's not.
You scroll down.
It's not. Here we go. Sorry. I'm so used to not Mac. Here we go. I have to go right to go scroll. And they all look good. I go down and they all look good. And there is one thing I wanted to show you. Okay.
But basically, the idea here is to
Limited.
look through the code.
Exactly. And in this case,
There was limited.
yeah, that's the term I'm looking for. Okay. So if you go of the 35, you might reach one that says limited lupus erythematosus. And that might pause you a little bit. Does that mean systemic or that's non-systemic? At this point, you can go back to your clinical partner. If you're not a clinician, you can look what this code is. If you Google it or Gen AI it will tell you that it's actually indeed a cutaneous, non-systemic condition of lupus. But there's two things you already learned. Maybe you don't want this code, but you also know that there's only 130 records in this code, in the data you're exploring. So whether you have it or not have it, maybe it's not going to make a big difference. But if you want to be accurate, at least semantically, you might not want to include this guy. And in this case, you can just press it, go down, go left, go all the way down, and it allowed you to exclude a concept that belonged to the hierarchy you selected, but exclude this guy. And you can exclude it with its descendant and then add to concept set. Now, if you look at the concept as expression, you have SLE not excluding, you see exclude is checked on the limited lupus erythematosus. So that answered our first question. Did I include everything? Is everything I included is legit? Now, what if somebody gave you a list of ICD-10 and you're like, but I want to know, did I include the ICD-10 that were given to me? Then in that case, you're going to go into included source code. And whatever that list that was given to you in whatever vocabulary, you can filter on that vocabulary. So if you were given a list of ICD-10, see now it's weird. Doesn't allow me to scroll. Here, it did, it worked. Okay. So you filter on ICD-10, and that's going to give you the list of ICD-10 that were grabbed with that standard representation. And remember that paper had M32.9, and you're like, did I include M32.9? Oh, here it is. Good. Or 9. Good. I have this. Did I include M32.1, which was also in that paper? Perfect. I have it. But you have others. And now you know that in the ICD-10, you have 10 codes that representing SLE. And you can, just similar to what you do with the standard code, you can go over them and make sure that this is things you wanted. If you were so worried about any source code, you would do that exercise. You can do the same thing. Just go over the semantic and make sure that there's no local, there's no cutaneous only, you're not adding rheumatoid arthritis. But generally, you can trust the mapping. You will find things that are SLE that maps to the standard. But if you want to, going back to that question, who decides on the mapping? If you want to check if the mapping is as you expected, then everything here should say SLE in some way. Make sense? Go ahead.
Please explain what the columns towards the right mean again. Sorry if I missed it earlier. RC.
Yeah. So again, those are the number of records that is loaded on each concept. So it's giving you the distribution of the records of actual patient level data for each record. They are coming from, in this atlas, they are coming from across the Odyssey community partners. So all the data partners contribute to something called prevalent concept data, which way they tell what's the count of the concept, what's the count per concept in their own data. So that tells you, give you an idea of what concepts are more prevalent than others. Oh, so that's the RC. The DRC, you'll see in a source code, the DRC and RC are the same. If you look at SNOMED or anything standard, you will see that the record count is the record count. The DRC is the descendant record count. So it's the records that are loaded on this concept and all its descendants. So it's summing up the entire hierarchy under that concept.
So that's in reference to the clinical data tables that get mapped to the standard vocabulary.
Correct.
Counting instances.
Exactly. So you'll see that the parent systemic lupus erythematosus on its own has 20 million records, but if you take all its descendants, it has 23 million. So there's like 3 million that are not for that concept, but for the concept that maps to it in the hierarchy.
So the limited lupus erythematosus, that seems not to be actually subsumed by the systemic one.
So in SNOMED it is, otherwise it won't show up. So you can,
So that seems like a mistake in SNOMED. Is there a way to feed that back into the upstream data source?
yeah.
That is a way. And we have wonderful people here actually connected to SNOMED, but it does take quite a lot of time for them to process whatever requests there are, because many people reach out to them and then they have their own vocabularies and you leverage hierarchies, you still want to check what's inside and compare it to your clinical definition, because your clinical definition will explicitly tell you what you want to include and what you don't want to include, and that may disagree with how SNOMED, Loin, ARCSOM, doesn't matter,
Yeah.
view these areas.
I actually just want to comment. So SNOMED has a content request system that you can access. You just have to go to the SNOMED site and get that information. And I love how you're thinking about it, because I think it's really important that when we, or your clinical expert partners, identify an issue in the source vocabularies, I think it's essential that we feed that back, because if you're having a problem, everybody's having a problem. And my own personal experience with SNOMED has been, SNOMED International does a release every month, and my experience has been that they are very responsive, unless it's, and particularly if you submit a reference that demonstrates the erroneous relationship, and typically we can see a change within. And when there's like, well, you do it within a month or 2 months. Sorry.
No, that's a very, very important point. Okay, so now we answered the question, is everything I'm including a legit and true code for SLE? And by exploiting both a source code that might be interested in or the included list is your way to make sure that this is true. And again, this tool allows you to, by click of a button, find the included concept and find the map concept. So far, so good? Make sense? Okay. The second question you're asking, wait, did I include every single SLE code across the vocabulary? Did I capture everything? Is there anything missing? Now, the tool also has a tab called Recommended. And what this list is, and it's going to be a different list depending on what your idea of interest. Here it has 58 concepts. This is a recommender system that is recommending for you codes or concepts based on your given list. So based on the list that you already arrived, it's going to recommend for you, in this case, 58 concepts. And the reason of why it's including those concepts going to be represented here. So it will recommend for you any concept that is in the OMAP vocabulary structure is a parent of a concept you included. Why is that? Because sometimes we are interested in a clinical phenomena, and it's named SLE. But when you explore the less granular concept of SLE, something that sits on top of it, its parent, you might realize that actually I'm fine if I give up some of my granularity and capture more patients that have a code on a higher level idea. And that's why it's going to represent for you the entire codes that are parents of your given list. So in this case, you're going to see 33 concepts that are recommended because they are a parent of one of your code lists. And that's checking with you of, are you willing to give up some of your granularity to gain a certain number of records? And when in clinical research, you'll see this all the time. In J&J, with our safety physician, they'll have an idea, and then we tell them we only have 5 people with this, but if you give up that granularity and instead of systemic lupus, you take any lupus, you'll have 100 patients. Is that of interest? So instead of you knowing that, this tool allows you to actually explore that. It will also recommend things for you based on lexical match. So it will recommend things because they have lexical match with your given standard concepts or with your source concept. So in case you're worried about some source code that have systemic lupus erythematosus wording in its description, but for some reason it's not mapped to that SLE in SNOMED, this tool would recommend this because it's gonna look at the lexical match with source codes. Does that make sense? So now we have 58 things that are recommended. So in your process, you will look at them, you will explore them, and you will make decision if any of these things is something you might want to include. So you will see very high broad ideas like kidney disease, disorder of the brain, because all of those are parents to some of your concepts that you included. One way of exploring this 58, you definitely want to sort it by the record count. But also, you can simply put your terms in there. So you can put lupus. Here we go. And look what you see. Now here are 21 codes that actually have the term lupus in them that you did not include them in your concept. And so maybe you want to explore this. So let's start with this one, lupus erythematosus. This is actually the parent of systemic lupus erythematosus. And you're losing granularity. What is the granularity you're losing here? The fact that it's systemic. So you can go on the hierarchy to check what is this code, and you will see that it is basically lupus erythematosus, and it has 6 children, and the first child is your systemic lupus erythematosus. But you'll see that you have cutaneous, which you know you don't want, you have drug-induced, you have neonatal, and so forth. So now the reason why this is important is many times in our real-world data, you'll find that a lot of the records are loaded on the parent. So it's not that they are not systemic lupus, it's just that the code does not indicate if they're systemic or not. So you could think that some of those cases, and in this case 1.8 million record, is patients with lupus. Some of them are systemic and some of them are not. You just don't know. And the question here, am I willing to add that code to gain more patients, knowing that I'm going to probably add some misclassified cases because some of them might be cutaneous. Again, that's a clinical decision that you might want to make with your team. But this tool allows you to see how many codes that it's not cutaneous, but it's not asserted that it's systemic in the code itself. And then you have to make that choice. But here you can see that 1.8 million records are with this code. But you have 25, but if you look at the record counts for systemic lupus, it's 20 million. So this maybe, if it was me, I'll say, okay, I have already 20 million. This is just adding 2%. Maybe I don't want them.
So would this represent records where the original diagnosis code was just not more specific than lupus in general?
Yeah, exactly. Okay. So again, every time you have to make a decision, go back to the concept set, and I'll go back to the recommended, which you have all the codes that the tool is suggesting for you. And a way of, instead of looking at all of them, just for sake of time, I'm just looking at certain example. Lupus. Okay. We talked about this one. We know cutaneous lupus is not something I'm interested in. Now you see something that says, disorder of immune function due to systemic lupus erythematosus. This is a patient with SLE, but the code is not SLE, the code is a complication of SLE, but it is a legit code of SLE. So you'll be like, oh, of course I want this guy. And you'll see that there are many, many codes of systemic lupus erythematosus that don't map to systemic lupus SLE itself, but maps to the complication hierarchy. If you didn't do this exercise, you won't see them. And this is the point of this tool is now not because it has this lexical relationship, it's bringing for you all the codes that whether in standard or in source have a lexical relationship with your given list. So now I can say, oh, of course I want this guy, I want the due to, I want everything that has SLE in it, and then you can select them. And if you know something about SLE, you know that it's because it's a systematic disease, it has a lot of manifestation in other organs. Go ahead.
It sounds like you want a ability to just select codes for complications of it, for instance, SLE. Is that an idea?
Yeah, let's see if that actually works. So imagine you're following this process, you select them, and then you select them verbatim, so you select all of them. You wonder, is there a code that has a complication that they all map to? Look what you do. You can do descendant, add to my concept. So now you added them verbatim. They might actually have a relationship. You save it, and then you press optimize. If they were all belonging, if there was a code that says complication of SLE and all of that's mapped to, it would remove that redundancy. Or you can look at yourself and see if there's something as this.
Which it did if you.
It did, yeah. So what did I do? Oh, no, cancel, sorry. So here you do, and then you override the current concept. Let's see. And it looks like they're all verbatim. It did remove some of them. Some of them were mapping to each other. It removed that, but it doesn't look like there's one parent of all complication that they all map to. If you would have seen the two, and then it would have mapped them to each of them. Did you all understand that question? So even though we're selecting code by code, if there were two codes and they belong to each other, like they're descendant of each other, I can still add them, and then I can press optimize, and it will understand that there are two codes that are redundant because you already have the parent and it's descendant, and it would remove that extra code concept. Okay. So that's how you use recommended. And now if I'm comfortable with this, I can say, well, I looked at all my codes. I looked what else I could be missing, and I added them. And now I have a concept set of SLE that I'm happy with, and it stays in your concept set. You can go back to it anytime you want. And that's pretty much it. There is a way. One question that always comes from tutorial is like, how in Atlas can I see what standard map to what source? So if you are in this is the last thing I'm gonna say. If you look at included concept and you look at the ICD-10, if it allows me to scroll, let's see, yeah, here. And you're like, wow, ICD-9 only have one code for SLE. I wonder, so here is SLE in ICD-9. It's only represented with one code. That's how ICD-9 is. And you wonder which of the SNOMED codes this SLE ICD-10 map to. You click it, and that will open kind of the card for this one, and you will go into related concepts. Patrick is calling me. And then you will say non-standard to standard, and it will show you that it maps to this standard. Okay? And I'll answer all the questions. Need to run to the other tutorial. Other than you learned that I can't spell, I hope you learned something about it.
Sometimes we now look for conditions, but we might have missed, for instance, things related to observations, because it might be something that you observe as a physician and you recorded an observation, and now that's not taken into account. So if we create concept sets now, we don't limit, for instance, the conditions.
No, we don't. We don't. So the question was, I think the question is even broader, which is sometimes it's not condition domain, it's observation domain. And there are gray areas where some of the things can be conditions, can be observations. So the recommender system will suggest you observations too if they're relevant. If there is a substring that has the same word, it's gonna show you observations too. But of course it's not always perfect. So sometimes it will miss some of the items, but you will get observations here. What you will usually not get is measurements and procedures when you start with conditions, but that's because the clinical idea, if it's lupus, then it's probably disease, so you think observations, conditions. If it's lab tests for lupus, then it's measurements. If it's procedures that are used to treat lupus, that's the clinical idea. Well, when you're saying, I want patients with the condition codes or diagnosis codes of lupus, that's condition and observation domain, and you'll get both. But if there are examples where there are recommendations or there are things you'd like to add, we would be happy to add that too, if there are some of the findings.
Speaking from experience, that's why where we initially mainly focused on conditions, and then realized, for instance, it was on acne, and acne scars, that's typical, added as observation, and so we have patients with acne based on observations, where we didn't have a disease code for condition, that's why, and we realized when we made this analysis, we really wanted to say.
Yeah, that's a very good point. Especially for the things that are borderline, you should also pay attention to observations. That's really the big takeaway, because some of the relevant things will be in the observation domain, not in condition domain. Or symptoms, or something that is borderline in between conditions and just a state. That's a very good point.
Exposures.
Uh-huh. Tell us more.
Right, I'm thinking kind of more like from a social determinants of health perspective.
Mm-hmm.
So that was kind of, when I saw cohort
Mm-hmm.
development, that's kind of the first thing I thought about was like exposures, and then I kind of think, and that's just the one that popped in my mind, maybe about other exposures. So is that, are we using this for that or not?
So when we say cohort, we just mean a group of patients that satisfy criteria. It doesn't have to do anything related to social determinants of health. You can create a cohort of patients that have certain social determinants. Like, for example, you can create a cohort of patients who live in a certain area, or those who have certain insurance, or those who are poor, or those who are of a certain race. That
I'm just wondering, are people using this like concept development for that kind of, and again, that's just kind of an example.
not really for social determinants of health, but the reason for it is that the data is not nicely represented. So there is a work group who works on actually coming up with good concepts for those determinants of health, and that's Health Equity Work Group.
I'm thinking, what about other exposures such as medications?
We will cover medications in block 3. So we're now all gonna do exercise on conditions. Then we're gonna talk drugs or medications, and then we're gonna talk lab tests.
Devices or sorry, I'm just
We
thinking
can-
from this exposure perspective, like, you know.
With the devices, there is no standardized way to find devices beyond do string search. It's a domain that is historically underrepresented, but there is work now done in the Greg project in Europe on harmonizing devices. So if devices is something that you care about or are interested in, reach out to us so we can connect you to people who will be putting time and effort into harmonizing devices so that we can come up with a similar tutorial for devices. Right now, it's just a hodgepodge of terms just sitting there. Any more questions? Yes.
Is the goal for devices, right, and then thinking about it, is it to create a similar hierarchy?
Yeah, a representation. Right now it's 10, 20 different vocabularies, all of them standard concepts. They're named differently, there is no common structure, there is no hierarchy. So if you want to find patients with devices, it's really hard because you need to do string search, but you don't even necessarily know what to look for because all of them are named so differently in different vocabularies. All right. Okay, so we are not getting sleepy. Oh, there is a question. Yes.
We are currently working on traditional data. So it's like Ayurvedic medicine.
Uh-huh.
The terminology is completely different.
Uh-huh.
So can we add that in regard codes if they have local codes from India?
I'll point you to that's a standalone question of adding content. I will point you to the resources that describe how to do that. We have vocabulary wiki page that outlines how you would add a content. Here we're talking about the existing content, how to leverage that. Awesome. Okay, so the faster we're done with the exercise, the faster we're gonna have coffee break. And I am very much looking forward to it. So we talked about lupus, and we are going to do rheumatoid arthritis. So we said that the description is really important, right? The clinical description or the clinical definition. So I'm gonna say a couple of words that will be useful for you when you're gonna build a concept set for rheumatoid arthritis. So rheumatoid arthritis, it's also an autoimmune disease. It affects joints. The important part about this disease is that it also can manifest in other organs. So it can have not only lead to deformities in your joints, but it can also lead in the changes in your lungs, in your heart, in your other organs. And that is the more general involvement of a body compared to just individual joints. Now, when you do it for real, you actually want to construct this definition. We distributed the email that shows some of the tools we use for the definitions. For the purpose of this exercise, really the only thing that you need to know to make your choices when you're going to be doing your concept set is that sometimes rheumatoid arthritis manifests with other organ involvement. Just keep that in mind. There is a list of codes that you can cross-reference that other people in their research thought should be included in the concept set of rheumatoid arthritis. This is not to mimic, this is not to recreate, this is just for you as an inspiration when you think about included concepts, to think, oh, what did other papers include, and do I want these codes? And we will keep that on the slide, on the screen so that you can cross-reference it. There is example, maybe we'll keep that just has bold ICD-10 codes, and there are numbers on the screen so that you can see that. To recap, because I feel like it's been a minute, the way you now are going to create a concept set for rheumatoid arthritis is that you'll find the proper standard by clicking on the shopping cart. You'll check the source codes included, you'll check the standard codes included, and then you'll check the recommend tab to see if there are other relevant codes. So this is what we're gonna do together in the next half an hour. We can stay as we are. We have nice groups in your tables. What one person or two, let's split each table into two parts. And so that's roughly going to be 3 people in each group, or you can do the table as a whole group. Within your group, find one person who's going to go to atlasdemoodyssey.org. So one person will now, say hi to each other at each of the tables. Awesome. Now now split into 2 halves for each table. You guys can do one table if you want. Now, as you split into 2 parts, now you have 3 or 4 people per group. Find one person who will go to atlas-demo.odyssey.org. You can also do DB in my atlas if you want. Go for it. Okay. Okay, so now you found that one person. Amazing. And you will start creating the concept set for rheumatoid arthritis. Now, if you want to back reference, here's the algorithm. If you want to back reference these slides or definition or the codes, the way to access them is, and I'm sharing too much of them. In the Odyssey teams, there is Workgroup Common Data Model, Vocabulary Workgroup, Files, Odyssey Symposium 2025, and the slides. But hopefully your memory is still fresh and you actually don't need these slides. I'm very much looking forward to see how good your memory works. But if you need these slides, they're here, and we're gonna be walking around to make sure you can click on buttons, you know where everything is, that we can help you out. But the goal at 2:45 to have a concept set for rheumatoid arthritis. Is it 2:45? Okay. Andy, CL? CL? No. No, if we're talking other vocabularies. Okay. So 2:45 we should all have, but hopefully faster, we should all have the concept set for rheumatoid arthritis. And we will now start perusing the case. So it was very nice that people were exploring all sorts of things. I feel like you're doing much better than, I shouldn't say that, but you're doing better than the previous cohort. So I'm gonna walk over how I would approach this problem, and then we're gonna have a break of 10 minutes. So the faster I do that, the faster we go on a break. So we want rheumatoid arthritis, and we said that the way we want to start is type in rheumatoid arthritis and click on the shopping cart. The shopping cart will recommend you the starting point that you want to start with. The starting point, not surprisingly, is called rheumatoid arthritis. It is a standard concept that belongs to condition domain, and it includes all descendants automatically by design. The next step for us is to look at the included concepts to see what kind of things we're getting. And we see that we're getting 135 SNOMED descendants. We can sort by a descendant record count to see what kind of things we're getting. And we can see here that the top is rheumatoid arthritis, then there is seropositive rheumatoid arthritis and seronegative rheumatoid arthritis. So now you know that there are two types of rheumatoid arthritis, positive and negative. Now, you can ask yourself the question, do I want both of them? Or maybe I don't want seronegative rheumatoid arthritis for some reason. Our clinical description did not say anything about about that, so here we assume that we want both, but looking at the descendants will prompt these questions of, do I actually want these terms in or out? And you can see that down the line we see rheumatoid arthritis of hand, of knee, of ankle, of wrist, of shoulder, rheumatoid vasculitis, which is rheumatoid disease of your vessels, not joints. But remember, in our clinical descriptions, we said sometimes rheumatoid arthritis can manifest in other organs, and that's fine, we still want that. So we do want rheumatoid vasculitis, even though it's not joints, because we said in our clinical description that we want other organ manifestations. And you would want to do this review to make sure that this list makes sense. And the benefit of reviewing is that when you see it, you can make a decision. If you don't see it, you don't know the decision is to be made. So that's why you want to look at the codes to familiarize yourself with the space of the codes you're including. In the same way, there are included source codes, and you can filter here by ICD-10-CEM, by ICD-9, by READ, by other vocabularies. And interestingly enough, we see that there are 2 codes in ICD-9, and there are 375 ICD-10-CEM terms. Now, going back to this list from the literature review, well, this is actually ICD-10, not ICD-10-CEM, but you can see that there are groups of codes M32, M32, L93, except for L93, the whole branch is really M32. So if you have this literature review done for you or by yourself, you can then look at this ICD or other source terms just to make sure that you are capturing the things that people previously identified in the literature. Maybe you don't want to, but you can use prior work of other people to think about your concept set. For example, here we can see that we also include a whole branch of MO5, and along with the MO5 branch, somewhere down the line, we will get MO6 and MO32. MO32 is going to be somewhere there too. So even though we're not going to review the whole 375 codes right now because it is unreasonable, the idea behind included source codes review is that sometimes, especially clinicians, have very good idea about what kind of source codes they want to include. So this is the tab for you to do the review to make sure that maybe they give you the list. Are all of the codes from their list included in this list? Or other things that you don't want? And then once you're done, we actually want all of these. Because we said we want joints, we want other organs, so we want all of these branches. And the last thing we want to do here is to click on the recommend to explore other things that we may want to include in our concept set that is not yet included. And there are different relationships. For example, the patient context gives you the suggestions of the codes that disproportionately co-occur in the patient data with the codes in your concept set. For example, the first one, rheumatoid lung disease, is not in your concept set, but it's oftentimes found in the patient data with the rheumatoid arthritis codes. And because we said that other body part involvement is fine too, we do want rheumatoid lung disease in our concept set. So we want to include that. And in the same manner, it's actually funny. I want to remove it for a second to show you something. It's actually funny that here you see rheumatoid lung disease and there is count 4. So there are 4 types of the sources of recommendations that leverage this term. So rheumatoid lung disease is suggested through the lexical search, through the ontology parent search, and through the patient context search. So there are 4 types of recommendations, all of them suggest adding this term. And we do want that. And in the same fashion, we would look through the other terms that are recommended through other channels. For example, ontology related is the terms that are in other branches of the hierarchies, but still in the Odyssey vocabularies. And here we see rheumatoid myocarditis, that's hard, and rheumatoid disease, we want that too. So we want to include this, and the same way we would go, and you see now it disappeared because you included that code in your concept set. There are also some of the things that are complications. Azza said that oftentimes watch out for complications. You can see when we look at the lexical via source, we go down polyarthropathy, too broad. Rheumatic heart disease, we don't want rheumatic, that's different from rheumatoid. Arthritis, too broad. Ankylosing spondylitis, just a different thing. Juvenile arthritis, different disease. But here we see myopathy due to rheumatoid arthritis. This is a complication. We want that because for our specific case of treatment pathways, we don't care, and I'm probably going into too much detail, but here we don't care about index event misspecification. I'm just gonna put these words out there. So we do want complications because myopathy due to rheumatoid arthritis means the patient has rheumatoid arthritis and developed myopathy. Sometimes we do care about when patient enter the cohort in which case we may not want this code. And if somebody is interested in this part of phenotyping, I'll happily talk about that over the break to make sure we're on time. We also see this complication, polyneuropathy in rheumatoid arthritis. We want that too. And we will go in the same fashion through other recommendations. And you will see that, for example, this term brings us 700,000 patients, which is not a negligible amount. So the idea here is that recommendations show you the things that you don't know, you don't necessarily know exist. And when you see them, you can make an informed choice of whether you want them or not. So that can be an example of a concept set. It actually has a couple of other terms from the recommend tab, but I'm going to skip them in the interest of time. The key takeaway here is that it includes the rheumatoid arthritis itself, but it also includes other organ of involvement in rheumatoid arthritis in our concept set too. Now, the question is, how many of you got to something that is close to this? Nice. Oh, we have a better concept set? Oh, longer. Oh, okay, that counts. When I say something like this, if you have better concept set, that definitely counts. Okay. Yes, there is a question.
So I had 148 included concepts.
Mm-hmm.
I added 2 that were observations that were from the recommended, and it was because it was disease prognosis for rheumatoid arthritis assessed, good prognosis documented, and another one similarly were poor prognosis documented, like disease prognosis for rheumatoid arthritis assessed. So I figured I could add this.
Yeah. This is a very good observation. So you found CPT4 codes which are used for billing in the US that specify that somebody talked to this patient, looked at their prognosis, which probably assumes that they have the disease, and documented that they have a disease and they have good prognosis. So for the purpose of our study, which is to characterize how those patients are treated, I don't care about specificity. I want as many patients as I can get. I want to increase my sensitivity. I would definitely include these 2 codes as well. That's a very, very good point.
So I noticed that you managed to get this number without having too many expressions.
Mm-hmm.
I went to recommended and added some things because I was looking at conditions due to rheumatoid arthritis, doing search for due to, and then found a few from my included concepts after that said like rheumatoid scleritis or vasculitis and stuff. So I happened to exclude some of those.
Okay.
I felt like my concept expression was still much longer, but like, how did you make yours kind of smaller but still have the same included concepts?
We'll just look at your concept set. I will come over to I haven't included all of them because then I will actually need to look through all of the things, which I'm not doing now. I'm just showing you the examples. Vasculitis, I actually explicitly said I want. So like you excluded vasculitis. I want vasculitis because it's rheumatoid disease that affects your vessels as opposed to your joints. Our clinical description doesn't say anything about excluding other organ involvement. So I am fine with vasculitis, but that would be informed by the clinical description. I told you that we do want other organ involvements for the purpose of this exercise. So for me, there was no reason to exclude it. But if there was a reason, of course, you would exclude it. Jack?
Yeah, I was thinking, as you add concepts from the recommend tab, does the recommend algorithm sort of Does it do any kind of machine learning where it looks back at your new concept set expression and says, "Ooh, let me suggest these"?
Yes. It's not machine learning, it's just pure computations of a vocabulary, unfortunately. But if you add this concept, for example, myocarditis, we added because it was recommended. Now, if we look at the recommend and try to find this term, we will not find it because it's already in the concept set. And also now, it provides recommendations for these other codes too. So it does computations on the fly. Awesome. Okay, I feel like we deserve a break. Do we? Do we feel like we deserve a break? All right. So let's do 10 minutes, but really 10 minutes. And the reason for it is that Polina's gonna do drugs. Drugs are really nice. They're really good. You do want to be there for it. And the faster we go through it, the faster we're gonna go and enjoy our reception, which I promise you I want to. So let's reconvene 3:10 here, and we're gonna go through drugs. It's gonna be amazing, and we're gonna do measurements, and then we're gonna do the fun reception.
Okay. So my first question, are you ready for the drug concept sets? Cannot hear. Are you ready? Yay! Okay.
Are we ready for the drug concept sets? Give us some noise. No, we can.
Woo-hoo-hoo-hoo-hoo. Yeah. More energy. So as you see, the next section is the drug concept sets. So we use drug concept sets for drug exposure table. And drugs are biochemical substances that have some effect to our body once introduced to it. And devices are not drugs, of course, it's clear. So let's start. In OMOP, different source drug vocabularies are mapped to common reference standard. Here you see RX norm and RX norm extension, but also they can be CVX for vaccines, but it's a secret. So the source terminology can vary, like RX norm, and it is interesting that RX norm is mapped to RX norm, but it's homopized RX norm in OMO structure. NDC, local terminologies, they can be different, so also, except drug source vocabularies, they also can be procedure terminologies. And you see here CPD4, HICPICS, or ICD-10 PCS. So some codes from these terminologies can be about drugs. And they are mapped also to common reference standard, RX norm or RX norm extension. And you may ask, what is RX norm extension? So RX norm is a terminology, drug terminology for the US market, while RX norm extension was created by Odyssey for non-US market to cover more drugs. And in some cases, you may find drugs of your need here in RX norm extension. So also, beyond the mentioned vocabularies, there is ATC, and ATC is interesting. So you can see ATC in the source data as a source vocabulary, especially in Europe. In the US, maybe not. But ATC also mapped to common reference standard, and at the same time, ATC is for hierarchy in the OMOP drug vocabularies. So we use it to classify drugs, and it sits above the RX norm and RX norm extension hierarchy, and allows you to group, to filter concepts, and you will see how to do it. Okay. So to understand the beautiful architecture of drug concepts in the OMOP, you need to know that this architecture works like a Lego set. It means that you can combine attributes of drugs like a building blocks in different way and get the specific concept classes. So here I took a pointer, but it's short, unfortunately, too short. Yeah, that is why, what can you see? Attributes, like upper part of the slide, Okay, thanks a lot, Anna. So you see ingredient, drug strength, dose form, brand name, and additionally quantified factor, box size, and supplier or manufacturer of the drug. And combining them, you can get different concept classes, as I said before. For instance, if you have in your source data only ingredient level information, so you will see the concept class of ingredient in OMOP. It's also useful for concept set. In some cases, we use just ingredients to get all possible drugs of different routes, and that's it. So then, for instance, the level of granularity of your source data is that you have ingredient plus drug strength, and you will get clinical drug component. Another instance, when you have ingredient plus dose form, and what do you see? There is no such a class. It's missing here, but there is another class, clinical drug form, and we will use it. Just remember that there is additional class when we have ingredient plus dose form without strength. Then, if you have ingredient, drug strength, and dose form, you will get classical clinical drug. Without any brand information, supplier, blah, 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 just clinical drug. Then ingredient, drug strength, dose form, brand name, you see branded drug, concept class. Very nice one, especially if you're interested in some brands. Then we have quantified factors added to that list, so the result will be quantified branded drug. Then if you have box size information, you'll get quantified branded box. And the last one, but not least, of course, it's a whole list of all possible attributes, from quantified factor, ingredient, all other things, box size, and also supplier or manufacturer of your drug. And it's called marketed product. So you know this, and I recommend memorizing these attributes right now. Please memorize it. It's very important because you should know these classes and the components of these classes for simple concept set creation. Okay, let's go further. So hierarchy. And what is interesting, in OMOP drug domain, we have two main dimensions of hierarchy. The first dimension is a Rx norm plus Rx norm extension hierarchy level, like this level. And in parallel, we have another dimension where we have ATC, which classifies this Rx norm and Rx norm extension additionally. But here we're looking particularly to Rx norm and Rx norm extension hierarchy. So to understand it, we need to look at concept ancestor table. Maybe you remember that Anna said that we are not going to deep dive into the table structure, but here we need to do this a bit, because concept ancestor table contains information about relationships, hierarchical relationships between concepts. There are the fields like ancestor concept ID for parents, descendant concept ID for children, and also mean and max level of separation. It's a distance between these relatives, like mother and daughter, or grandmother and grandchild, and further. So first level here at this dimension, Rx norm and Rx norm extension hierarchy, is ingredient level. So you start from ingredient, and then you will get all the descendants. So let's click, and we will see the derivatives of the ingredient. So also two axes, clinical drug component and clinical drug form, also clinical dose groups. For some reason, for instance, you would like to get all oral products, capsules, tablets, extended release, delayed release, and if you select these groups, you will get all these dose forms, like clinical drug forms. So we have these two branches. Then they merge into clinical drug. And what is a clinical drug? What attributes are there? Who remember? Ingredient. Yeah, drug strength. And dose form. Yes, very good. So, okay. Then, after clinical drug, you will get branded drug. So brand is added to the list of attributes. After that, you might see like a derivative of clinical drug component. It's a branded drug component. What does it mean? We have ingredient, drug strength, and brand. What is missing here? dose form. Yeah, that is why it's branded drug component. In parallel, we have sibling of this, like branded drug form, ingredient, dose form, and brand. What is missing? Drug strength. It's possible to have it in your data. Then, at the end, you will get quantified branded drug for liquids and marketed product. All attributes are there: box size, manufacturer, brand name, all of them. So you can use this beautiful hierarchy, and the drug domain is really the best in the OMOP. It's very cleanest, very nice and straightforward. So now we have scenarios to create this concept set in Atlas. First one is just to find ingredient, particular ingredient. It's a methotrexate, will be. Then the second one, ingredient is a certain route of administration, methotrexate oral. Then combo drug, like trimethoprim plus sulfamethoxazole. First scenario, class of drugs. Here we will be using ATC because ATC gives us groups of drugs. Tumor necrosis factor inhibitors will be there. And the last one, class of drugs with a certain route of administration. It will be also ATC, but with a route of administration, like systemic corticosteroids. Okay, so first scenario, sorry for this sound, so ingredient. What we will do, we will choose the ingredient and all descendants, simplest concept set ever. So, okay, come on top. Oh, yeah, I'm there.
Well, Polina's speaking.
Oh, I did it, but it's as always.
Just to clarify, this is the case where
You want to start?
Okay. So search, as you remember from the previous exercise, we will start here. What we're trying to find, methotrexate. Okay.
let's see how you can spell.
Methotrexate.
Oh, you actually can spell. That's so nice.
Yeah? Oh, okay,
Yes.
good. And I will click on the search button because for drugs, usually we do not use recommender. Yes? Okay. So let's wait. And we need ingredient. It should be standard. And here, in terms of colors, we have blue line methotrexate, and we know that is standard. And violet, or what is the color, it's classification concepts. From ATC, usually some SPL, but we do not need them. We can filter just for convenience, like standard. If there are a lot of them, yeah, we can click here, then click on this checkbox, please click, and then scroll down, include descendants, this tab, yes, all drugs related to this ingredient. Add to new concept set. Oh my God. Okay, and then we are fine. So concept set tab is in red. It means that something is inside this tab. So now looking at the concept set expression tab, we see the methotrexate is here. Descendants are included. Now we can look to the included concept. There are a lot of them. That is why it's fine, very quickly. And we have a lot of different drugs. From RX norm extension, like more than 5,000 concepts. From RX norm 200. Then different classes of different granularity. All of them are here. So we are so happy to see all of them. And we also can click on included source codes just for the case. I don't know. Yeah. We have some NDC codes mapped to RX norm. You remember from the first slide, NDC was there, RX norm mapped to RX norm, some SNOMED concepts, so it's fine. So we are done. We can name, enter some name here, save it, but as you understood, we did this first concept set. Okay, let's come back to the scenario number 2. Okay. Second scenario, please click on that, then check. Oh, maybe this one. Please work. Not like that.
Do you want to go to the
Slideshow, I would like.
I assume this is fine. 'Cause
Yeah?
you can do-
Oh, okay. So the second scenario, ingredient with a certain route of administration. And here you see like upper, what is that, right corner for you, ingredient, derived to clinical drug form at the end. What is clinical drug form?
You can do it.
Yeah, I'm sure. Ingredient plus dose form. Yeah, dose form. Very well. So what we're going to do? Choose an ingredient. Oh, this plus this sentence, and then within this included concept list, we will select appropriate clinical drug forms. Plus this sentence, and we also remove ingredient, because if we remain ingredient, it will retrieve all other drug products we do not need it. Okay, so let's come back, clean it up. Yes, I'm sure, and search. Okay, the same steps. Methotrexate. I'm repeating it from the beginning, but of course I was able to reuse the previous one. But okay, methotrexate ingredient, then this sentence, then add to new concept set. Okay, and then go to the concept sets, please. Touchpad doesn't feel my fingers. Okay, so included concepts. And what should we do here?
We should filter to something.
Yeah.
What should we filter to? Class? Standard, yes.
Agree.
Standard. You don't get second. I'll second. Standard.
I'm trying to click on it. Oh. Okay, so what about class? Clinical drug form. Yes, yes. Don't be shy. Clinical drug form. Form here. Oh, yes, yes. What it was? Oral? Oral. Okay, so we need only oral forms. I will use this filter, oral. And you see capsule, solution, suspension, tablet. Nice. For instance, you can click here, and then you will see this something changed, and it's terrifying, but don't pay attention. It means that all needed concepts were selected. Just ignore this. Go down, then click on this sentence, and add to concept set. Okay. Then concept set expression, come back to that. And the last step we should do is what? Remove ingredient. Yes, very well. Remove selected. So we are done. We did everything. We add oral forms. That's it. Okay, next scenario.
Oh, that's good so far. I'm feeling that we're going into post-lunch.
Yeah. But if you have any questions, please let me know. And third scenario, combo drug combinations, trimethoprim and sulfamethoxazole. So we will use one ingredient, and here it's quite interesting. You see the schema. Ingredient goes to clinical drug component. It's ingredient plus what? No, drug strength. Component, it's a drug strength. Oh, dose, oh, sorry, drug strength, yeah, apologies. And clinical drug form, it's a dose form plus ingredient, we know it. It means that we can find combination drugs only within these concept classes and their descendants. So we cannot find combination drug at the ingredient level. It's impossible in OMOP. That is why we need to remember that we can find for them in component or in the drug form, clinical drug form. And here you see this picture like T, it's for trimethoprim, S for sulfamethoxazole, and combining both ingredients together and selecting clinical drug component, clinical drug form, we can get these combinations. So talking about instructions, ingredient plus descendants, first step, one of them. Then within included concepts, we will try to find all the combinations that we need. There is no restriction about a number of ingredients except these two. there can be more ingredients in this drug. That is why we can use them as well. And the last step, which I can't forget, include branded drug components if there is record count more than 0. Okay, let's go. Yeah, we just clean it, then go to search, and trimethoprim. We need ingredient, standard ingredient. So here we can filter by ingredient. Oh, here we are. This is trimethoprim, click on it, then descendants, and add to new concept set. Good. Then come back to concept set, and the next part is included concept section. And here we need to filter by class. So what is the class we need here? First word, clinical. Then drug. And the last is what? Form, correct. Very good. So clinical drug form or component, you remember, component also possible. So here we need to select only combinations with sulfamethoxazole and trimethoprim. To do this, we need to filter here by the second ingredient with very nice spelling, sulfamethoxazole. Okay, sulfamethoxazole, xatoxazole. Okay, it's enough. So yeah, here we are. All these drugs contain sulfamethoxazole. Was there any limitations for the route of administration? No. It means that we can select any kind of drug, injection, oral, whatever. So let's quickly check through this list. Everything is fine. Then click here, select all. Don't be afraid. Scroll down. Then descendants, add to concept set. Okay. And now we have 2,000 plus concepts with combinations of sulfamethoxazole and trimethoprim. So we are happy, we did it. But we forgot something. First of all, remove ingredient. Very important step. Okay, remove selected. Good. Also, potentially, we can add clinical drug components. We can try. But I removed ingredient, that is why we will skip it. So, but you can do it if you would like in the exercise later. Okay, let's come back. So the fourth scenario, we almost done it. So class of drugs, tumor necrosis factor inhibitors from ATC. If we're talking about some categories or groups, we will choose ATC. In real world, there are 3 scenarios when you usually can use ATC, or why you use ATC instead of RX norm. First one, for instance, your clinician in the loop find some ATC codes and said use them because I need the literature or something. The second option, if your source data contains ATC, for instance, you are in Europe and they use ATC for coding, can be this. And the third scenario, you just would like to find category as we're doing here. You know that, I need all tumor necrosis factor inhibitors, but I don't want to Google or something. I just want to pick this group and got all of them just in a second. Okay. So here we need to recall information about hierarchy. So we remember that above the RX norm extension dimension of the hierarchy, we have ATC. And the first class that we have there is ATC fifths. ATC fifths in ATC is ingredient plus route of administration, like methotrexate systemic. And this class is connected directly hierarchically to clinical drug form. And clinical drug form is ingredient plus dose form, without drug strengths, just dose form. Okay. Okay, it's not that. So if we go further, we will see other classes of ATC. So above fifth class, there is other immunosuppressants, broader category. The third class, immunosuppressants excluding corticosteroids. And the higher we go, the less details we have. So less granular concepts are there. If we can use them. In our task, especially fifth scenario, we can use, for instance, second class of ATC or third class of ATC. It depends on context. Let's go further. It's our scenario, what we need to do. We will select ATC that represents the class of our interest, and we will retrieve all Rx norm or Rx norm extension ingredients that belong to this class. Very logical. Then we will use Rx norm ingredients plus descendants. That's it. It's a simple scenario. So let's go there. Okay. Yes. Search. And here will be tumor necrosis factor. We can filter by vocabulary. We know for sure that should be ATC, only one option. In violet means that is classification. So we click on this checkbox, go down, descendants, add to new concept set, then come back to concept sets. And here, in the included concepts, we need to find what? Ingredients. Ingredients, yes. It's a simple way, because if we'll go through the whole list, like 2028 concepts, it's a lot of time. That is why just ingredient and voila, 5 ingredients. Yeah, 5. So we need to click here, then scroll down, descendants, and add to concept set. Okay. Come back to concept set expression, and just for, clean sake, we can remove the ATC classification from that list. We do not need it anymore. Bye-bye ATC. And that's it. So concept set is ready, we are happy, and we can go to the last scenario. Fifth scenario, class of drugs with a certain route of administration. It will be systemic corticosteroids, a bit complicated. But here you see that ATC level from 1 to 4 give us connection to ingredient and also to clinical drug form. So here we will do the following. We will take ATC with descendants and remove ingredients themselves. Why we remove ingredients? Why do we remove ingredients? How do you think? Any ideas? Because ingredients are not specific. There is no information about route of administration, and it means that it can be not just systemic, for instance, local corticosteroids, like, I don't know, ointment. That is why we need to remove them from hierarchy in our concept set. Okay, let's do that. Systemic corticosteroids. Okay. Search. I will start from corticosteroids. Corticosteroids. Okay. A lot of them. So filter by vocabulary, ATC, nothing has changed. So let's try to find something. Okay. Combinations. We do not need combinations. In our description, there was no information about combinations. Let's ignore them. And now we need to find appropriate ATC class. For instance, corticosteroids for systemic use. Looks pretty much good. Let's check it. What is hidden behind this concept? So, hierarchy. And here we have 3 children. Corticosteroids for systemic use plain, this is nice. Then corticosteroids for systemic use combinations, we do not want combinations, at least now. And then, surprise, surprise, anti-adrenal preparations. What does it mean? It means that these drugs act in opposite way as corticosteroids. If you do not know this, of course, clinician in the loop can help. But here we know that anti-adrenal preparations, it's a wrong class of ATC, we do not need it. That is why let's use this one. We can click here, then descendants, and add to new concept set. Yay. Come back to concept set, and we have 18,050, a lot of things, okay. 859 concepts. So what we need to do next? We need to remove ingredients. Okay. We will go to included concepts, then filter by class, ingredient, like 20 ingredients here, click here, then scroll down, then exclude, but we do not click on descendants, because if we do that, we will exclude everything. That is why just exclude and add to concept set. Very well. Let's check. Injection, prefilled syringe, blah, 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 injectable solution. So it seems like all systemic forms are there. I made this conclusion just analyzing one page from 377, but I just can use it. I don't know. Atlas works well, that is why it's not a problem. So come back to concept set expression, check what we have. We have excluded concepts and corticosteroids for systemic use plain, descendants. So that's it, we did it. Okay. Any questions? No? Oh, yeah, please.
So what does it mean if you search for an NDC code and it's not found in Atlas, but you know it's a valid NDC code?
NDC? And it means that potentially this NDC code can be not in Athena, in vocabularies. It's my opinion.
So there are actually two things. The first thing is that NDCs with dashes on some of the websites, we don't do dashes, so there's going to be zeros in some of the places. So instead of looking for a code, you can find a name and then see if there's no.
That wasn't the issue. The issue is that we have a couple of codes that maybe are new codes that are not mapped, I think, but I want to be sure.
Then it can be the second scenario, where RxNorm doesn't have it yet, because the way we get it is through RxNorm distribution files. So the next refresh, if it's not in August, the August uses July RxNorm. If something was published in August, then it's not going to be in vocabularies yet. Or there can be a case that those NDCs are not in the RxNorm distribution, in which case you can open up the issue on GitHub to log it in so we can look at it. And there is a whole, albeit slightly dead, initiative to collect all sorts of NDCs from different pharmaceutical companies, because not all of them are in Athena, because not all of them are in RxNorm distribution. So if you want to add that, GitHub is a good place to create an issue.
Okay. Thank you.
And maybe also the version of vocabularies in Atlas can affect this, yes?
Yeah, I'm talking about.
Oh, okay.
All right, so there were no questions. We all assume, I know that's not right, but we assume that you got everything. All right, so now your task for each group is to do all of these 5 in the next 30 minutes. The first one should take you really 5 seconds. All right. So you will start from first scenario to the second, to the third, to the fourth, to the fifth. Those who got, and you have, actually is cheating. The
previous groups didn't have slides. You have slides for reference that you can use. Those who got, the group who got to all of the concept sets, I brought something very dear to my heart from Germany, where I was visiting my friends. This is very nice cookies with marzipan. They would go to the group who gets to do all of these concept sets in the next 30 minutes. And of course, we got a person to help you, and you have slides for reference too. In the first scenario, you want all drugs containing the I cannot spell. In the second scenario, you want drugs that have sulfasalazine, but only oral forms, no injectable. Third one, you want drugs that have both amoxicillin and clavulanic acid. In the first one, you want drug class of interleukin inhibitors. And the fifth one, we want you to replicate systemic corticosteroids, because I cannot count the number of times somebody asked me how to create a concept set for systemic corticosteroids. So please don't be this person, replicate this. All right, so with that, we are 3:48, 3:50, 4:20. We're gonna reconvene with these 5 scenarios, ideally done. I do have some backup candidates in case more than one group completes this exercise. All right.
Is there any punishment?
Punishment? No, we don't do punishments. If you need any help, please let us know. And we'll get you.
Okay. Another housekeeping thing. We divided you into groups and asked one person to do Atlas. Why? Because there are 5 tutorials. Each of them is using Atlas. Atlas is slow. It freaks everybody out. It's very annoying. So within your group, please pick one person who's accessing Atlas so that nobody freaks out that it's not working.
Hi again. I'm Masha, and I'm a technical lead of the OHDSI Vocabularies. And now we will proceed with measurement concept set. So no exercise, relax, and enjoy. So if we are talking about autoimmune disease, we will use as an example C-reactive protein, which is a commonly used marker of inflammation, a substance produced by the liver. C-reactive protein may be measured in various body fluids, but as we are eager to diagnose lupus, we will use blood as a body fluid of interest. When we talk about measurements, we should remember that they're a bit tricky. So measurement itself consists of a procedure of measurement, a lab test, and the result of measurements, values. Values can be categorical, recorded in the text form, such as normal, abnormal, increased, decreased, etc. And also values may be numerical in your data, recorded with numbers. And in case of numerical data, one of the crucial things is units of measure, which we need to know to properly define our cohort. And to create the cohort with the help of measurements, we should follow these steps. Firstly, we should determine the list of lab tests we want to use. Then we add exclusion or inclusion criteria, where we set up thresholds and values which we are interested in. Then we find correct units and exclude implausible numeric results if they are. If we speak about how measurements can be present in your data, they may come from different sources. For example, and depending on the source, they may be represented differently. For example, if your source data come from claims, for example, CPT4 maybe, then you will likely see only the record of the measurement procedure, but you will not see any values for them. And on the opposite side, if we examine AHR data, likely you will see both measurements and the values. And now we proceed to the first step and define the code list for the lab test, and namely for our C-reactive protein. In OMOP, we map all the source data to standard. Source data may be recorded as a free text, and this free text may vary significantly. There may be acronyms, they may be fully defined terms, but with different spelling, with dash, without dash, and so on. And also, your source data may be recorded using commonly used terminologies such as ICD family vocabularies or READ. So we map them all to standard vocabularies. Standard vocabularies for measurements are LOINC and SNOMED. Let's look precisely at them. The heart of the OMOP vocabularies is SNOMED. SNOMED is beautiful. SNOMED has a rich hierarchy, and from high-level concepts to the more specific concepts. And also, one of the main features of SNOMED is its lateral or attribute relationships. For example, if we look at the procedure, for example, C-reactive protein measurement in Athena, you will see that it has a relationship has interprets, which will lead us to the possible results of this procedure. For example, C-reactive protein, flying candies, okay. C-reactive protein above reference range. In the same branch, you will see C-reactive protein below reference range, etc. And we may see the relationship has component, which leads us to the substance we are interested in, C-reactive protein. If we choose C-reactive protein, we will see all the measurements that are available in SNOMED for C-reactive protein. So you may browse in SNOMED like swimming in the sea, and it's very, very fascinating. On the other hand, we have LOINC. LOINC also has a hierarchy. The main difference is that hierarchical concepts in LOINC are classificational. They are not used in the data, but LOINC lab test concepts are widely used and may be present in your data, and you may see that they are very, very specific. They contain both substance, both body fluid or substance of our body, which we use as a material for our examination, and the I don't know, not units, but units. Yeah. For example, in this case, it's mass volume, so we may expect that units will be, for example, nanogram per deciliter or etc. What is the feature of OMOP vocabulary is that we unified and joined SNOMED and LOINC into one hierarchy, where SNOMED, with its rich web of relationships and more high-level semantics, is apparent for LOINC. And LOINC, as an end leaves, are embedded into the SNOMED hierarchy. In this way, we map your source data to these standard concepts, and depending on what do you have in your sources, we may map them to the procedure, to the SNOMED procedure of lab test. It would be measurement domain, but still a procedure of lab test. Which is a high-level concept. If your source contains more specific data, we may map it to LOINC. Or, for example, if you have ICD, usually measurements are recorded into the R group category of ICD codes. And they are presented as a pre-coordinated, so they have a procedure in its concept name plus the result. So you will see that elevated C-reactive protein is mapped to the clinical finding C-reactive protein above reference range of SNOMED. And all of them are measurements. So now we will look more precisely at our very concept set, but I will remind you about the main steps. So firstly, we will find the proper standard concept. Then we check the source concepts which we have included in our concept set. Examine Phoebe's recommendations. And the main feature of our concept set will be that we will go to the SNOMED lateral relationships and learn how to use them to enrich our concept set. And now, Anna, I've forgotten how to switch to Atlas Dima. Something.
Maybe next time we're not going to use my laptop. I'm arriving at this feeling that
we should vote for Windows or Mac.
I'm pretty sure the vote's not going to be for Mac.
Oh, thank you. So, as usual, we start with the search tab, and we will type here C-reactive protein. Oh. Caps lock?
Caps lock.
Yeah. C-reactive protein measurement. If you know how to spell precisely the lab test, you may proceed with green button. But if you don't know, for example, you don't know, do you need any dash or some other signs, you should better look at the blue one. So here we will click on the shopping cart and look at our concept set expression. Everything is okay. We have added, and our recommender added a C-reactive protein SNOMED, high-level SNOMED concept, which subsumes all the procedure of all the respective lab test procedures. Let's look at them. What we have included here. I have broken everything again. I will try. Give me a chance.
Okay. Let's not expose all of the G&G secrets.
No,
No, I'm kidding. There is none. I'm sorry.
And I will bring a mouse next time. Okay. So we are lucky. We have only 20 rows. So let's look at them. A C-reactive protein in blood. Everything is good with it. That's precisely what we want. We will keep it. The next long concept, pay attention. C-reactive protein in body fluid. The thing is, Loing distinguishes between blood and body fluid. So blood also is body fluid, but it doesn't fit us here. So we should go here, click on this concept, and now we may wonder if we have other Loing concepts which measure C-reactive protein in body fluid, but not mass volume, but maybe concentration moles volume or other units. So we should go to the hierarchy, and in the hierarchy we see classificational concepts of Loing C-reactive protein in body fluid chemistry. We may choose it and exclude all the descendants. So we exclude all the concepts that represent measurements in body fluid. We exclude them, add to our concept set, go to our concept set, and we see only 18. So the one that we chose, that we saw at first was not the one. There was again one more concept of Loing that, with body fluid substance. The same thing with cerebral spinal fluid. It's also not what we want, so we choose it. Well, go to the hierarchy, choose this Loing classification, descendants, exclude, add to our concept set. Oh, 16, perfect. Go further. C-reactive protein in serum plasma. Serum plasma are parts of our blood, so we also want them. Everything is okay. And row by row, we review our concept set and see some interesting CPT4 concepts, which represent measurements of C-reactive protein. However, it also includes other components, and we may assume that it's a panel. Usually we don't want panels for our research, so we should exclude them. CPT4 has no descendants, so we may not choose descendants. Add to our concept set. Haba. Yeah. Here we have the list of lab test procedures referring us to the measurement of C-reactive protein. Can we breathe out? No, we cannot, because we remember that, for example, ICD-10s are mapped to the pre-coordinated concepts in clinical finding concept class, which represent measurement and its result in one concept. How should we find it? We go to C-reactive protein measurement procedure, look at the related concepts. Oh, my fingers. Go to the filters and look at the relationship tab. Here we find interprets of, choose it, and we see clinical findings of SNOMED with the results of C-reactive protein measurements. As we are interested only in the disease, so we may assume that C-reactive protein within reference range is not a concept of our interest. So we choose above, we choose outside, and choose their descendants, and add. And now we can say that we are done with our lab test code list. And now we should. Yeah. Comment tab, yeah. Comment tab, First tab, sorry. Thank you. As I said in the beginning, the code list of lab tests is not sufficient if you want to fully define our cohort. And following, when we add inclusion criteria, we should add values that define our range of interest. For example, in case of C-reactive protein, the abnormal range of CRP starts from 0.299 milligrams per deciliter. And here we also add the upper threshold of 10 because we assume that C-reactive protein above 10 may also lead us to the infection disease, which we don't want to add to our concept set of autoimmune diseases. At this step, you should know how measurements are represented in your data to know what units you need to use here. We have a tool called ARES, which shows in very beautiful way how what units are present in your data for each specific type of measurement. So if you don't know, please use it or pay attention. It's very, very interesting. So we assume that in our data, CRP is measured in milligrams per deciliter. So we added it here. At this time, this step, we may assume that our concept set is ready. Thank you.
Homework. Yeah, no, there is no homework. Okay. You know, I was just checking that I'm not tripping, and it's supposed to end at 5 and not 6, because I was like, well, the networking is from 6, so like, why is it there is an hour and a gap, an hour gap? Anyway, so you guys have slides for reference. You could see that maybe measurements were less intuitive or required more steps than conditions. And that is because measurements are standardized not as well as conditions or drugs. And if you're interested in research on units, on lab tests, on doing characterization of network, on doing studies with the lab tests, please reach out to us or Phenotyping More group, because we need more people to actually drive initiatives for standardization of measurements. Until that, you can use their slides as a reference point for you to start your concept sets for labs, but be ready that you will need to do a lot of exploration of your own data, because people do ETL, the lab tests, in a very different way. So thank you, Masha, for a very, very nice demo of the lab tests. In the interest of time, we're going to hang around here if you have any subsequent questions. If no, please enjoy your time. I'm sure we will see each other at the networking reception too. There's going to be an interesting scavenger hunt. So I'm going to come because I think it's going to be fun. I've been promised it's going to be fun. So please come to the networking reception too. If there is any feedback in terms of the workshop, please feel free to tell me or to send me a message in Teams or an email, which is my last name at odyssey.org. Thanks so much for coming. If there are any questions, we will be here for another 10 minutes.